let's talk about a key use case. Let's set the context. Imagine a fictitious retail commerce company, such as Look Commerce. You recently launched a product which is doing really well in the market, but you see that some of the products that were launched, there's like a return rate about 5%. And the marketing team wants to understand, hey, what's going on? Like, what can we do to mitigate this problem? And can we build this through an Iceberg Lakehouse? So let's dive deeper into the use case itself. We start with an open lakehouse on Apache Spark. This is a completely prompt-driven notebook. So, like, for example, here's an example on how you can build a notebook inside our IDE, where you take a prompt and just use Gemini to generate the code snippets. So in the interest of time, I've kind of completely built the notebook. But you can see here that it's pretty easy to use. You just start right away, prompt it with what you really want to do, and then you can start setting up like the Spark connection and so on and so forth. Under the hood, we are using the Lightning engine that Emmett mentioned with the 4.x performance. So here we are actually setting up the Iceberg REST catalog along with the access to GCS file I/O with differentiated performance and security using credential vending. Once the catalog is wired up, we actually load all our retail data into a set of Iceberg tables. So we have the total retail return list. We immediately access this data, and then we want to combine it with the products data. So we get the products information as well, and then kind of start classifying these retail tables and over a certain period of time. So to actually create the retail tables, we create a catalog and a namespace inside the Iceberg catalog. So we create the retail return catalog, and then we start creating the return table. So here's the actual return table. So this tracks returns over a certain period of time. And so now I basically see that this is a managed table. So it has table management enabled. So out of the box, you create a table, and you can say, hey, also please manage this table for me. So it takes care of garbage collection, compaction, pruning. So now you can see that you query this table and insert some records into it. So we have inserted a bunch of return records. So you can see it's very quick with the Lightning engine. And then we immediately look at, OK, over a certain window of time, here's my total aggregated returns. And here's the aha moment. So we see this data and over a certain window of time. And now we want to see, can I access this in BigQuery as well for deeper insights? And I immediately see it in the BigQuery console. I have the retail table. I get some details about it. And then I say, OK, great. I want to now query this table. So I go ahead and then basically run a query in my favorite SQL editor in BigQuery. And then I say, OK, great. So I'm able to see the retail returns on Iceberg with the REST catalog. Now I say, OK, I want to learn a little bit more about the return products. So I run an AI generate function using the latest Gemini models on this data. And then I get descriptions of the specific products that were returned over that window of time. So as this works through, it's using the latest Gemini model. So here's the descriptions. And what we'd like to do is now take it a step further. We would like to actually converse with this data and understand a little bit more about retail patterns. So what we do is we start a conversation using conversational analytics. So this uses the conversational analytics agent. So I want to learn a little bit more of this data. So I ask for, hey, what's this data about? What are the fields? So it gives me an overview of the different fields in this data. So it's very easy to use right out of the BigQuery console. So this gives you a quick overview of the schema with details about the specific fields. And then now you want to understand a little bit more. Like, tell me which are the products that are actually really returning, what's the trends, what's the segmentation, and so on. So we ask it a set of questions around that. So could you provide me a little bit more insights on which product category is actually being returned? And so the agent actually analyzes this data. It's probably looking at the same data on GCS, on your Iceberg table, which was ingested from Spark. And then it's going to come up with some patterns on the returns, plot a histogram, and actually give you some insights on specific product categories. What you see here is now that the agent has processed it, you can see that the different retail products, what segments they're returned on. You see that specific groups of products are returned more often. And if you're not using an agent, in an earlier ecosystem, you would have built a custom pipeline to figure this out. So you see that shorts and pans are probably the most returned products, and you want to get some more details on why. So once you know that the specific leading category of products, you can then prompt the agent to basically say, hey, can you tell me a little bit more about why this is happening? So what you can actually now ask it for is, hey, give me a specific set of reasons why these products may be returned, or any other such insights. So let's prompt it to understand why the returns are actually happening. It talks about the seasonality patterns that were there in that period of time, which was around January. It also talks about specific size and fit issues with certain specific products, and also like specifically travel returns as well. So it gives you specific insights on the return patterns itself. And now it helps the marketing team to actually take actions on this data. So what you can see is that the Lakehouse 1.0 or 2.0 journey that we talked about, we've just seen that here right away. We started with a notebook, loaded the data, got it in Iceberg, immediately queried in BigQuery, used an AI function, then used an agent to actually solve the problem. And I did all of this in 8 minutes. So that's pretty neat, right? And now you can actually productionize this agent and expose it to executives in your organization who would like to know why this is happening and build a dashboard on it as well. Furthermore, let's take it a step further. We talked about governance. So we can immediately start looking through this retail data in the knowledge catalog to understand key governance capabilities that you want to, like who's accessed the data, what's the lineage that is needed, what's the data quality, can I get specific insights on this as well? So here's an example where the unified governance, which is a key problem we started off with, one of the key enterprise problems as well, which is being demonstrated with lineage. How was the data generated? What was the different set of engines that are querying it? Furthermore, you can actually see that it's backed by the Iceberg REST catalog using credential vending. You can also figure out where the resources is, where the bucket is, so on and so forth. So what we demonstrated is basically a set of key capabilities all within Google Cloud. But what if we take this a step further and have a cross-cloud journey? Like, imagine a second use case where a college basketball team is actually rebranding their basketball team, and they want to pick a mascot. Now, this particular team that's like the university where they're building this application, it's all hosted on Google Cloud. And however, the data set that they want to access the mascot's data is on another cloud. And it's an S3, it's backed by Iceberg and Unity Catalog. And the SQL analyst on the basketball team, he's like a grad student, so he knows to use BigQuery, he loves BigQuery, and then he would like to query this data cross-cloud. So they have a setup where it's already wired up with Unity Catalog, and we have configured it with Unity Catalog, and we're immediately able to just run a simple SQL command and query the entire mascots table cross-cloud from another cloud on Iceberg. So here's an example where the student is actually running this to get some specific list of mascots from the mascots data set, which is cross-cloud, and then would like to then start running conversational analytics to pick a particular mascot for their basketball team for the rebrand. So I won't go deep into this demo, but what this is demonstrating is the exact set of capabilities we talked about, which we're doing within Google Cloud, can be transcended cross-cloud. So any data, any cloud, any boundaries, in any format. With that, I will kind of wrap up. We announced a bunch of capabilities in our AI-native cross-cloud. We talked about openness with zero compromises, and we actually demonstrated it. We also talked about a borderless cross-cloud foundation, which we saw with our mascots use case, built for the agentic era with the conversational analytics.